Chapter 18 is about formatting responses. In SAS there are formats and informats, and the formats change how data values are printed in the results, whether it's a graphic or one of the analysis methods. Informats convert how the data are stored, and so we're not going to work with informats. There are some formats for responses that SAS has already predefined, and there are some that are user defined. That is, that we can do that, and we define those formats in a procedure called proc format, or the format procedure. So it allows us to keep our data entry simple, perhaps for on surveys just giving 1, 2, or a Likert scale 1, 2, 3, 4, 5, and we can convert those to more meaningful text values in our analysis or on a graphic. We can do some things that format things such as phone numbers as well. All we are concerned with is entering the 10 digits, and we can impose a format on a 10-digit code to get it to look like a phone number. The format procedure produces formats that are global in nature, and so we have 3 different statements that we're going to look at. First, the picture statement, when you provide a name using and the name here follows SAS naming conventions, and then the range of values, and you look at what the picture options are that you can impose here, and we'll look at examples. The second is a value statement, where the name of it, and you specify the name, but we're looking at values. The ranges here observed in our data are numeric. Likewise up here in the picture, they're numeric. Here, whenever we have character values, then the name of the format will be given by a $sign followed by the word name, and the values in the data that our variables take are specified here in quotation marks. Now you can have multiple picture statements and multiple value statements in a single format procedure. It's not necessary to separate all of them, and these create a format. The formats they create then are global, and they exist for this SAS session. And so that again, on the formats, we want to keep things valid here with the format names that we use SAS naming conventions, and so it's a template that we wish to apply to those responses. And so that typically we see values for ranges 1 through 10, those kinds of things, but you can also put low values to high, low to 100 if you don't know what the lowest measure is or you don't know what the highest measure is. And so to encompass everything, you can just say other or low to high and for a single picture statement. The quantity in quotation marks are the formatted value expressions that we defined. You can put in prefixes so that if we have everything needs to be followed in an A first, and then the numeric code, chapter numbers, item numbers, whatever text you want as a prefix. You can also use a $sign, but SAS has some predefined formats using for monetary units that we may choose to use instead. Fill equals character is that if you have perhaps leading zeros or some other information, then that's repetitive, and so you can use that to fill the space. And so there are a few other options given here, and so we'll see how these pictures statements then are applied. The value statement then defines a format for either numeric or character variables, and so whenever it reads a particular numeric value, it assigns text to that value. Likewise, for a character response, when it's enclosed in quotation marks, what is the format you wish to have applied to it. So the only difference here is in the name of the format. So again, following SAS naming conventions, if it's a numeric variable, you just use the word name, and it's $sign name if it's a character variable requiring a format. Once we have formats defined, or if we're going to use a SAS created format, then in order to apply it in a procedure, we need a format statement. So every procedure that we have done so far that produces printed output could have an additional statement in it called format. And in the format, you look at the variable and then what the format you want applied to it. And so then whenever you invoke the format, you follow it by a period. So it's format 1 period. And you list each variable followed by the format you wish to be applied to it. Okay. You can have several variables. So here an illustration where there are 3 variables and they all have the A format applied to it. When you have number values in your data, you can impose formats on this, and so that you look at a format and it's given by W period D or W decimal D, where W is the entire width of the numeric value and D is the number of decimal places, and the decimal point occupies one of the W spaces assigned. So whenever you look at the example here is format, the response is use 5.2. What that means is we have a width of 5 and 2 decimal places. So in position 3 you're going to see a decimal point. SAS has also created monetary format, so it's dollar and WD. There's no space in between here, and so typically we look at the D being 2 decimal places, since we typically express monetary amounts in hundredths of units or cents, and so that and W is the total width of the field. This dollar format also places commas once we get in excess of 999. $X WD reverses the role of the comma in the decimal in monetary expressions such as used in Europe. There are similar monetary formats for euros. There's a comma format, which is the same as the dollar format, except it doesn't have the dollar sign prefix, such as we would see with each of these monetary amounts. And so that we'll look at the following example to illustrate how these work. We're going to look at we see titles, labels, etc. Kind of a compilation of everything we've seen so far in the book. Our variables that we're looking at are an identification, a level of experience, salary expressed in thousands of dollars, region of the United States, a gender question, our variable, a yes/no responses for the level of degree, and a group classification identifying subjects as either being from engineering, business, or science. So all I've done is just created 4 observations here. I do have a missing observation, and so that here input, their ID, notice I have some leading zeros here, experience, the salary in thousands, region are given by these numeric values, the gender is written 1, 2, we have a missing and a 3, and we can keep going here. So we can run the format procedure. It's not going to generate any printed output, but we can express these all in the same procedure. So I have 3 picture statements. I call these A, B, and C. So other, remember, it gathers everything, or you can write low to high, but it just says other. So it's going to apply this picture or this format to all of the IDs here. So much like we see Social Security numbers, when it encounters those leading those zeros numerically, the zeros are dropped, and it's just read as like 171,831. Well, if we want to keep those zeros, then we can say fill equals 0. Picture B, we have 2 decimal places here, so perhaps that's what we want to look for salary information, or we can request that there be the 6 digits here with a prefix being a $sign, so we can look at those and the effect that has whenever we'll just do a simple print on these. When you have a numeric variable such as salary, you can create a salary format. So this is kind of this is a me thing, and perhaps the person that first showed me formats tended to put FMT. So this, at the very beginning, I recognize this as salary format, and then whenever I impose it, I'll follow it by a period. So it'll be easier for me when I look at my programs to determine which ones are variables and which ones are formats. So from the lowest salary up to 49.9, I'm just going to assign that this text below 50,000, and then these number ranges here similarly define a text to describe that interval. I'm using single line comments here so that it's a reminder to myself whenever I take some time away from the program and come back to it, I realize what I'm setting up. I identify numerical regions to parts of the U.S. So in this case I have Northwest, Central, and then 3-4 Southern. Suppose you had a Southeast and a Southwest, and I just decided to make all that into Southern. And then we have a format that can assist with missing values, and so if you put a period in here, you can say that it's missing value. If it picks up anything other than what's mentioned here, it's perhaps miscoded. This is a print error here. These 3 dots here should not be, it should be 3 spaces. You can give the responses, say for a survey, if you had 1 and 2 for yes and no. So 1 is our yeses. It doesn't matter what language you don't want to put them in, you can write that. So we have the degree question, the degree response in Russian, or that you can write the yes, no in Spanish, however you wish to label that. When we look at the groups for engineering, business, and science, these were given values in the data set E, B, and S, so therefore it's a character value, so I need to write a $sign in front of that group format. So once you submit all of this, these formats exist in SAS memory until we exit or replace them. And notice in all of these, when I have group and I had several lines or multiple lines here, I just punctuate it with the semicolon here. This was all one single SAS statement here in one line, so punctuated with the semicolon here. I'm using, again, single line comments to assist me in identifying the information in this program later. So in Objective 1, I can create this data set 1, and I have this information entered as a data set. I can create all of these formats that we had written above in the book, and then I get to proc print, and all I want to do is print. I am formatting the ID using the A format and salary using the B format. So I invoke the format, so it's A period and here is B period. So let's scroll back up. A says for the IDs I want to fill in this code, and if I have leading zeros, it's going to place a 0. For salary, then it's going to use this information. So if we take this and highlight everything down through that print procedure, alright, now if I go back to the program code for a moment, all that was requested here is that I print everything. I only format 2 of the variables, so there is no VAR statement, so I did not have to have a VAR statement here. I also have no options on the proc print statement. And so what happens up here in the IDs and the salary, those were the 2 things we formatted. The rest of it is everything we formatted stayed exactly the same. Now there's something to point out here in the IDs, because if I scroll back up to my data, this first ID number has 3 leading zeros, and then it hits that hyphen that was in that picture format. And so whenever I had the leading zeros, then it actually covered that hyphen in there. So instead of 3 zeros hyphen, 17, I ended up with an extra 0. And so then for the salary was this information here, and what it wanted was 2 decimal places, and so that was achieved. So that one's very subtle. In the second objective in Chapter 18, we want to modify this print procedure, and we want to use the SAS Social Security number format, SSN, for the ID, SAL format for the salaries, and format all of the remaining variables from the user-defined formats. I put the label option on the print procedure. Remember, that's going to expand the column headers over what I see here, and then all the rest of these variable values in here will have a format applied. So ID is Social Security, salary format, salary 2. I put a second C format on this. Let's go back up and see with a C format. It says to budget 6 spaces here and use a prefix. One of those 6 spaces is going to be a $sign. I can use the region format, the gender format, the degree format. So notice that all 3 of these responses have the yes, no, degree format here, and then we have the group format. So that if it's a SAS format, it's followed by a period. If it's a user-defined format, it's followed by a period. Multiple variables can have one format applied, and character variables can have a character format applied. We'll get to objective 3 shortly. So on screen, do it this way. I have just these 2 in front of me so I can see what happens with the ID numbers. That was the Social Security number format. Fix this first ID. Notice the column headers are now written using the labels rather than the short variable names in objective 18.1. Then these salary intervals are created. That's the SAL format. This is where I had the 6 digits with a $sign prefix, and so that if I had a 6-digit income, I would need a 7-digit format to be able to put the $sign there. Region of the US, so that was just the 1, 2, 3, 4, and I get that information. Gender, if we're uncertain, we could say missing value or miscoded, that didn't apply to what we were measuring. And then on the degree information, the yes no information, so this person got a bachelor's and a master's, and then we have here someone who no for a bachelor's but has the 2 advanced, so it depends on the nature of this. Perhaps it is at a particular university. Their groups, they were given by letters, and now we've spelled that out. So we control the order of the variables here by the VAR statement. So that's how salary 2 got moved. So that was the VAR statement. Now, if I left the VAR statement out, they would be in this order, and same as in objective 18.1, but the formats would still be applied because I've used the format statement. Now in objective 18.3, we liked the way that Social Security number format looked. Salary 2 was a measure, and we put the dollar format that SAS has defined, and then the salary itself. Here we can just say we want 7 spaces applied to it. A total width is 7 with 3 decimal places. And we only had 3 variables printed here just to see the results. Okay, and so I have here like the Social Security number look that it gave me here, salary 2. Have the information above where I didn't request a prefix, just a number of decimal places, and then salary in thousands, and then it was to request a total of 6 spaces, and 3 were decimal places. Pardon me, 7 spaces, 7.3 spaces. So now just a quick demonstration for the beef data we've been using. We're going to need to format the responses there. So recall we measured which producer, the sex of the animals, and then they had numeric values. And so the numeric measures are what they are. I don't need to change those. For the value of the sex variable, if it's written as H, I want it to spell out heifers, and if it was written as S, I want it to spell out steers. The reason is that's going to look more informative on a graph. Likewise, I created another format. This one is a numeric format. There's no $sign, whereas this one has a $sign. And so that my producers were given as 1, 2, and 3. And so if it's 1, it came from Rocking K Ranch. If it's 2, it was the Superior Beef Company, and 3 was Royal Beef Producers. Then in Objective 18.4, we can look at G-chart, where we look at the vertical bar chart for sex and how many animals of each sex come from each producer. And so within the procedure, we format both variables, the sex variable and the producer variable. And I'm just using solid gray here. And I forgot to run we're going to need to grab our library name statement here if we've not created that library already. So the effect of having those formats, notice what happened down here. This looks much nicer, more informative. We have to be careful if they get too long, because there are things can get terribly congested here and actually even override each other. So you don't want the formats or the variable labels to become too long for that reason. All of the other things we could have done with a vertical bar chart and G-chart apply. So you can still change colors, you can change bar length, you can change axis labels. All that stuff still works. All this allows us to do is to change things here, whereas previously we made this chart before and it was HS for each producer, and the producer was 1, 2, and 3. So we've made this chart before. All we did was make it look a little better here. An extraneous run statement here. And here, so this is any kind of a graphics procedure. We can get things labeled. The means procedure, same data set, specifying the mean and the range for the variables dry matter intake and ribeye area for each sex and producer combination. And so here, the same 2 formats as we had above. I don't need to run that format again, but the idea will show you what happens when you run an analytical procedure versus a graphics procedure is the point here. So when I finished this, previously I would have had H and S and producers 1, 2, and 3. And so by using the format within the procedure, then this applies. And so I get all of this same information. And without the format, if we turn the format off, that's enough to do it. So the format still exists, I'm just choosing not to use it. Okay, so here you have H and 2, 3 and steer 1, 2, 3. So you can the headers cut off up at the top, but here we have the same. We have a little better information. So if you're getting ready to produce a report, it would look much better for you to have this, unless there was some reason you needed to maintain confidentiality of your producers, and you can keep them as 1, 2, and 3, or you can specify what their names are. Likewise, the label, we've seen this before. The label's in both, and the label occurs in the data step. The format is created in the format procedure, and so you can choose then to use the format in the procedure or not. If we would have placed the run statement ahead of the format statement, it would have run and not used the format. So you want to be careful. If you want it to pick up that format, make sure you put the run statement in the right place. So this is just a quick way to look at things. It's a really nice way to improve the appearance of graphics by having this information in there. If you think about doing proc report, we saw proc means, proc freak, any of those kinds of things where you have the 1, 2, 3s kinds of answers, all you'd have to do is format those answers and to go from a simple numeric scale to something that looks better, much better in a presentation.